just concentrate on the lesson now. Don't worry about others. Two nuclei have their mass numbers in the ratio of 1:3. Mass number. So A1 by A2. Two nuclei have their mass numbers in the ratio of 1:3, 1/3. The ratio of their nuclear densities. What are the ratios of densities? Rho 1 by rho 2. Is it, if the ratio of mass numbers is 1:3, what are the ratio of densities? 1:? It's 1:1 because density does not change, density remains same. Density of nuclei does not change, density remains same, right? If the mass number increases, density will not change, because mass number increases, the volume increases. So it's proportionate, whatever the mass number increase in mass number, so proportionately volume increases, therefore density remains constant, therefore it is 1:1. So these are some questions like you will have to remember, right? In Coulomb's law, force between any two charges, it's 1:1, something similar to that here. So these are standard questions that might come in the examination. You can just simply answer this question without any thinking about it. It's 1:1. Okay, next question. So 7th question. Question number 7. If the nucleus, right? If the nucleus aluminum 13, 24, correct now? If the nucleus aluminum 13, 24 has a nuclear radius of 3.6 Fermi. So nuclear radius of aluminum is 3.6 Fermi. 3.6 Fermi. Then this is Te. What is Te? 32. And I think it's not 32. Is it 32? Huh? What is Te is what? Huh? Terranium? Te? 32? No, that is wrong actually. It should be more than, I think. Even aluminum is also not, 24 is not correct. 27 aluminum. 27, right? 64, huh? Sure, huh? Are you sure? Do one thing. I think it's similar to the first question, 5th question. You can just do it on your own. Find out that. You can just take it as a homework and find out what is the actual mass number and proton number of terrarium. Okay, next one, 8th question. Question number 8. The radius of germanium nuclide is measured to be twice the radius of beryllium. So radius of germanium, R of germanium is twice the radius of beryllium. So it is, beryllium is it is 4,9 beryllium. Radius of germanium is 32, correct now? Atomic number 32 germanium. So the number of nucleons in germanium are, what are the number of nucleons in germanium, right? So we have this R is equal to R naught into 8 to the power of same formula. So now radius of germanium is R naught into 8 to the power of 1/3. We have to find out this. Now radius of beryllium is given, it's twice na. Germanium is twice, okay, right. So radius of beryllium is R naught into, this is germanium and this is beryllium, correct na? Artha aita? Radius of germanium is R naught into 8 to the power of germanium 1/3 and radius of beryllium is R naught 8 to the power of 1/3 beryllium. Now we will have to find out germanium, radius of germanium. So therefore divide this R germanium by R beryllium is equal to a to the power of 1/3 germanium by a to the power of 1/3 beryllium. Okay. So now, but they have given this is twice. So therefore it becomes 2 na. Our germanium is twice beryllium. So in place of germanium I will write twice beryllium. So twice beryllium cancels here. So I get 2 here. Now this is a to the power of germanium 1/3 beryllium they have given, it is 9, correct now? Beryllium is 9 to the power of 1/3, correct? Now take cube both sides. When you cube this, what do you get? 8 into 9 na? So this is germanium. So therefore a germanium is 72. Artha aita? Huh? Okay, therefore so mass number of germanium is 72. Next 8th question. 9th question. Question number 9. The energy required to break one bond in DNA is 10 to the power minus 20 joules. Okay. So energy required to break one bond in DNA is 10 to the power minus 20 joules. The value in electron volt is, so it is given in joules, so we will have to divide this na. Electron volt means we have to divide. So in electron volt means 10 to the power minus 20 divided by 1.6 into 10 to the power minus 19. So which will be, okay, 1 by 1.6 into plus 1 na, sorry, minus 1, right? Correct. So therefore it is this can be written as 10 by 16. I am just doing the simplification. So which is 0.6, correct? 0.6, correct? 100 agatidu. Then I am left with 4, 6, 2, 5 into 10 to the power minus 1. So therefore it is 0.0625 electron volt. So 0.06, option number C. Option number C. Question number 9. Huh? 10th one, yeah. Question number 10. The energy equivalent of 0.5 grams of a substance. Energy equivalent of 0.5 grams of a substance. So I told you energy equivalent of 0.5 grams delta m into c squared, right? Energy equivalent of 0.5 grams is delta m into c squared. So it is 0.5 grams to kg is minus 3, correct now? Gram to kg, you have to convert this gram to kg, minus 3 into c squared is 3 into 10 to the power of 8 meter per second square, speed of light. So therefore it is 0.5 into 9 into 10 to the power minus 3 into 10 to the power of 16. So this is 4.5 into 10 to the power of 13. So option number B, correct? Question number 11. How does the binding energy per nucleon vary with the increase in the number of nucleons? How does the binding energy per nucleon vary with the increase in the number of nucleons? First increases, then decreases with increase in mass number, correct now? So you are all familiar with binding energy curve. So initially it increases, right, and then reaches a maximum value. For iron it is maximum and then goes on decreasing, like as the mass number increases the binding energy decreases. So therefore first increases, then decreases with increase in mass number. Okay, so option number C. Next one is that the mass of lithium, the mass of a lithium Li, it is lithium 3, I think it is 6 na, 6 or 7, what, it's not printed properly there, 7, lithium 7, okay. Lithium 7 nucleus is, the mass is given 0.042, 042 atomic mass unit, U means atomic mass unit, AMU, it is less than the sum of the masses of all its nucleons. this mass, this is mass of the lithium nucleus, right? It is less than masses of all its nucleons. The binding energy per nucleon of lithium nucleus is nearly. What is the binding energy per nucleon? Okay, per nucleon of lithium nucleus is nearly. Okay, so we know binding energy is nothing but, right, it is, this is the entire nucleus. Binding energy of entire nucleus is the Z into mmp, correct now, plus A minus Z into Mn minus M, right? So here the Z is given na 3, right? But here they are not given mass of proton and all. Okay, so this is roughly 1.67 alva atomic mass units. 1.67 ಅರ್ಥ ಆಯ್ತಾ ಹೇಳಿದ್ದು? 1.67 mass of proton is 1.672 in 10 to the minus 27 kg, and one atomic mass unit is roughly 1.67 into mass of proton is 1.67 plus A minus Z is 4 into mass of neutron, little higher than this. I think it's 1.67, we can take it as 1.68 minus mass of the nucleus is 0.0042. This is the mass of, okay, atomic mass unit. I think how much you'll get? 0 point? Yeah, 1. Can you simplify this? Simplify this now. This is mass of proton is almost equal to mass of neutron. Okay, just you can take it as 7 into alva bariboda. So it is 7 into 1.02 minus 0.042. Subtract ಮಾಡಿ. 6 point? 6 point? 6 point? How 7 point? 6 point? Will you get 7? How much you get? 7.098. So this is basically into c squared na. Binding energy, this is only mass defect. Delta m into c squared, correct? Delta m into c squared, right? So this is since it is given in okay, atomic mass units, we have to multiply with 931 MeV. Artha aida? Are you clear? Since the mass is given in atomic mass units, 931 MeV, this is also 931 MeV. So you multiply this 931 MeV. How much you get? Multiply this 931 MeV, electron volt. How much you get? 6608.238. Final answer 6608.238 into 931. Oh, multiply mega electron volt, na? Okay, I'll just check the answer. It will not be so much. Huh? See, answer. How it is 5 point? How is 5.8? Okay, anyway, I'll just check the answer. Afternoon session, I'll tell you what is the correct answer. So we are, what are our options given? We are getting 6,600. I'll let you know the answer in the afternoon. Second session. Okay. Next question, 13th question. I think that's what. I'll just check and tell you. Okay. Next question, 13th question. I think mass of proton and that will vary. I'll let you know about it. Okay. Next question. 13th question. If M A comma Z, M A comma Z and M and M, okay, denote the masses of nucleus ZXA, proton and neutron, right. So these are MAZ. MAZ denotes the mass of ZXA, and M is mass of proton and other M is mass of neutron respectively in units of atomic mass unit, and binding energy represents its binding energy in MeV. Then which is the correct option? Binding energy, is it option C? ZMP MNZ MN minus MAZ into binding energy in MEV they have given. Okay, I think in such a scenario it is MAZ, ZMP MNZ MN MAZ C squared, should be 931 MEV. 931. Okay. But how it is option C? MAZ, it will not come first now. So this is the equation, right? Binding energy. Binding energy is given by delta M into C squared, right? So if it is in 931 MeV, binding energy will be equal to delta M into 931 MeV. Correct now? Is it correct? So this is in MeV, this is in C squared, joules. So binding energy in MeV, this remains same now. This is ZMP plus A minus Z, Mn minus M. This remains same into 931. Correct now? Correct? So these are in masses. So going by that, then it should be first option only, no? Because he said it is in MEV, but it is not given in MEV. So going by that, it's first option. Are you clear? So it's not given in MEV. If you had given in MEV, you should have multiplied with 931. Arthadalido. So this equation is not given in MEV. So it's given in terms of joules only. So option 1 is correct. ಕೊಟ್ಟಿದ್ದಾರೆ ಬಟ್ ಆಪ್ಷನ್ಸ್ ಅದರಲ್ಲಿ ಇಲ್ವಲ್ಲ ಆಪ್ಷನ್ಸ್ no not like that, we have to convert. I will tell you that. Okay, so I think I'll tell you how it is. Okay, so we'll not spend much time on this, we'll go to the next question. I will tell you a nucleus ZXA, same 14th is over, na? Okay, right, okay, next we'll go to 15th question. 15th question, I think I was referring to, okay, now, okay, I was referring to options of, correct, right, now it's, so for question number 13 I was referring to options of 4, that is where the mistake. Okay, now 14th question, option A is correct now? 14th question, option A is correct. Wait, 13th I'll tell you. So 13th one, MAZ, M and M denote the masses of nucleus and neutron respectively. Correct, option C. Option C is correct. Correct. No, I was referring to the options of 14. See, for 13th question, artha agtidya? Option C only. Going by this equation, for 13th question, it is option C. You know why it is? So because binding energy is given by, as per this, Z mp plus A minus Z mn minus m into c squared, correct? Now the binding energy per nucleon, so what happens, binding energy by c squared, correct now? You get Zmp plus A minus Z into Mn minus M. So this is nothing but ಇದನ್ನ ಈ ಕಡೆ ತಗೊಂಡಾಗ ಇದು ಈ ಕಡೆ ತಗೊಂಡ್ರೆ ಅಷ್ಟೇ ಬರುತ್ತೆ. So therefore M is equal to okay, so option C. Okay, for question number 13, option C is correct. Okay, next question. Question number 15. Fission of nuclei. 15th question. Fission of nuclei is possible because the binding energy per nucleon is in them is. Fission of nuclei is possible because the binding energy per nucleon in them increases with mass number, decreases with mass number, increases with mass number with high mass numbers, decrease with mass number at high mass numbers. Increases with mass number at low mass number. Decreases with, they are saying fission, not fusion. Fission. Fission is decreases na. Decreases with mass number with high mass numbers. So therefore option number D. So nuclear fission is possible with higher nuclei, higher mass numbers. So as the binding energy decreases, so therefore they get easily dissociated. Next, 16th question. The mass of proton is 1.0073. I think now we got it here. The mass of proton is 1.0073 atomic mass unit, and that of neutron is 1.0087 unit atomic mass unit. The binding energy of helium is given by. So, Martira, will you do it now? Quickly do it now. Quickly do it. .4 MeV. Got the answer? Yes, sir. Okay, next one. 17th question. Question number 17. If 17th question, if the nuclear forces between two protons, two neutrons, and between proton and neutron is denoted by FPP, FNN and FPN. Okay, so if nuclear force between two protons, two neutrons, between proton and neutron denoted by FPP, FNN, FPN and respectively, then F we are talking about nuclear force. We are talking about nuclear force. We are not talking about electrostatic force. We are talking about the nuclear force. Nuclear force between two protons, between proton and proton, and between two neutrons, and between proton and neutron. So how are they related? Are same. Correct na? Option C. Right. But actually, listen here. Since there is some kind of repulsive force, there is some amount of repulsive force between proton and proton na, and neutron no electrostatic force, and here also there is no electrostatic force. Therefore here correct answer is FNN is equal to FPN, right, which will be greater than FPP. ಅರ್ಥ ಹೇಳಿದ್ದು. ಸೊ ಸಾಮಾನ್ಯ ಆಪ್ಷನ್ ಈ ಥರನೂ ಬರುತ್ತೆ. ಓಕೆ, So in some exams I have seen this option. So in case option is, one of the options is like this, because proton and proton both are charged charges, there is a repulsive force, and nuclear force is strongest force. It will be, nuclear forces will be greater than the electrostatic force. But so when you compare this nucleons, force between them, Fnn is and Fpn both are equal. It's only nuclear force, no electrostatic force. These two will be greater than that. Okay. So but here in this scenario, so we have to take all of them approximately equal. Option number A agata. All of them approximately same. So option C tarana barbodu. Artha ಹೇಳಿದು. So normally FPP is less than other two, but in this scenario, because going by the options, they will not be equal. So they will be approximately equal. So FPP is approximately equal to Fnn, approximately equal to Fpn. Artha aida? Is it clear? Okay, next question. 18th question. So which of the following statements is true for nuclear forces? They are short range force. Yeah, option number C. Next one, radioactivity. 19th question. So alpha particle, 2 protons and alpha. So it has 2 neutrons. Option? No. ಒಂದೊಂದೇ ಹೇಳ್ತಾ ಹೋಗಿ. It doesn't have any electrons. It is a helium nucleus. Helium nucleus, no electrons. It has 2 protons and 2 neutrons. Arada, 2 protons and 2 neutrons. So it doesn't have electrons. Arada, everybody is clear? It has only 2 protons and 2 neutrons. Right. Next one. Question number 20. 20th question. The rate of radioactive disintegration at an instant for a radioactive sample of half-life is given. It is T of, it is 2.2 into 10 to the power of 9 seconds. So this is the rate of radioactive disintegration. So rate of rate of disintegration is R is equal to 10 to the power of 10 per second. Artha aida? The rate of radioactive disintegration at an instant for a radioactive sample of half-life ಕೊಟ್ಟಿದ್ದಾರೆ 2.2 in 10 to the power of 9 seconds is this much. This is the rate of disintegration. R is given. The number of radioactive atoms in the sample at that time. So we know this R is equal to n lambda. Familiar equation ido? Are you familiar with this equation? The rate of disintegration R is equal to n lambda. Are you familiar? Right. R is equal to n lambda. So R is given 10 to the power of 10. N is, we have to find out. Lambda is, we don't know. So how will you find out lambda? 0.693 by T of. So 0.693 by T of is 2.2 into 10 to the power of 9. So which is 0.693, 2.2 into 10 to the power minus 9. I'll make it as 6.93 10 to the power minus 10 divided by 2.2. So which is roughly, I can take it as 3 na? 3, you take it as 3, no problem. 2.2 into 3 is basically 6.8, 6.6 alva? Correct? Approximate ಮಾಡಿ 2.2 into 3 is 6.6 alva? So 3 ಅಂತ ಬರ್ಕೊಳ್ಳಿ. 3.1 ಅಂತ ಏನೋ ಬರುತ್ತೆ, ಪರವಾಗಿಲ್ಲ, ಇಷ್ಟು ಬರ್ಕೊಳ್ಳಿ. 3 into 10 to the power minus 10. So this is what? Decay constant. So therefore it is 3 into 10 to the power minus 10. So therefore n is equal to 1 by 3 10 to the power of 10 by 10 to the power minus 10. So what is the correct answer? So this is basically 0.33 na? 10 to the power of 20. So therefore it is 3.17 into 10 to the power of 20. Sorry, B is option. Option D is the answer. Option A, option B same agide. Okay, option D is the correct answer. 21st question. For a radioactive material, off-life is 10 minutes. Off-life is given. T off is 10 minutes. Off-life is 10 minutes. If initially there are 600 number of nuclei, so N0 is 600 number of nuclei. N0 is given. So for a radioactive material, off-life is 10 minutes. If initially there are 600 number of nuclei, the time taken in minutes for the disintegration of 450 nuclei. For the disintegration, 450 nuclei disintegrated. What are the number of nuclei left? 150. Correct? Number of nuclei left is 150. Artha huh? Time taken to disintegrate 450. Number of nuclei is this. Therefore, n is equal to n0 into e to the power of minus lambda t. Correct? Right? Now n is how much? 150. N0 is 450. Sorry, 600. 600. E to the power of lambda. Lambda is 1 by 10. Correct? Into t. Okay. So this is 4. Correct? So therefore, 1 is equal to 4 here. We can take this to denominator. So t by 10. T by 10, correct? So therefore, it is e to the power of t by 10 is equal to 4. ಬರಿಬೋದಾ? ಇದು ಡಿನಾಮಿನೇಟರ್ ತಗೊಂಡಾಗ ಪ್ಲಸ್ ಆಗುತ್ತೆ, t by 10 ಆಗುತ್ತೆ. ಸೊ ಈಗ log 4. t by 10 is equal to log 4. Log e, not natural logarithms. Natural logarithms, or therefore t is equal to 2.303 into 10 log of base 10 4. Base 10 convert ಮಾಡಿ 2.303 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀರಾ. ಅರ್ಥ ಆಗ್ತಿದೆಯೇನಪ್ಪ ಇದು? ಯಾರಿಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಇದು? Okay, you would have done this in board part, board numerical. Okay, so let us find out what is the value of log 4. Anybody has a class? Huh? Yeah, 2.303. This is one. No, either 10 multiply ಮಾಡಿದೀನಿ ಇಲ್ಲಿ. Huh? Okay, ಆ ಥರ ಬರ್ಕೊಂತೀರಾ. ಇಲ್ಲಾಂದ್ರೆ ನಿಮಗೆ ಕ್ಲಾಸ್ ಟೇಬಲ್ ಇದೆ, find out the values of 4. We can write that also. Anybody is? ಇಲ್ಲ 0.3010 ಬಂದು log 3 ಅನ್ಸುತ್ತೆ. log 2 ನಾ? log 1 ಪಾಯಿಂಟ್. log 1 is 0 ಪಾಯಿಂಟ್ ಆಗುತ್ತೆ. log 10 ಇದ್ರೆ 1 ಪಾಯಿಂಟ್ ಆಗುತ್ತೆ. log 100 ಇದ್ರೆ 2 ಪಾಯಿಂಟ್ ಆಗುತ್ತೆ. ಅರ್ಥ ಹೇಳಿದ್ದು? ಎನಿಬಡಿ ಇಸ್ ಎ ಕ್ಲಾಸ್ ಟೇಬಲ್? ಇದು ಮಾಡ್ಕೊಂತೀರಾ? ವಿಲ್ ಯು ಸಾಲ್ವ್ ಅಟ್ ಹೋಮ್? ಕ್ಲಾಸ್ ಟೇಬಲ್ ಇದು ಯಾರ ಹತ್ರ ಆದ್ರು? ಓಕೆ, ಜಸ್ಟ್ ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್ log 4, just multiply. You get the time. Answer D. ಅಲ್ಲ, log 4 ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಾಯ್ತಾ? log 4 ವ್ಯಾಲ್ಯೂ ಗೊತ್ತಾಯ್ತಾ? What is the value of log 4? ಇದೆಯಾ ಕ್ಲಾಸ್ ಟೇಬಲ್? log 4 480. 480. 4 ಇದ್ರೆ ಕ್ಯಾಕ್ಸ್ಟಿಕ್ 0 ಆಗುತ್ತಲ್ವಾ? 60. 6 ತಗೊಳ್ಳಿ. So 23 into 0.6, roughly about 15 ಬರುತ್ತೆ. 15. Option number D. Okay. We go to next question. ಆಯ್ತಾ ಇದು? 22nd question. Radioactive material A has decay constant 8 lambda. Okay. Radioactive material A has decay constant 8 lambda and material B has decay constant. So material A has lambda. Material A has B has lambda, A has 8 lambda. Correct na? Decay constant lambda. Adna lambda anta ಮಾಡ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ print ತಪ್ಪಾಗಿದೆ. Make it as what has been printed there. Material B has decay constant lambda anta ಮಾಡ್ಕೊಳ್ಳಿ. Make it as lambda. B has decay constant lambda. Okay. Initially they have same number of nuclei. Both of them have same number of nuclei. Both of them have same number of nuclei. After what time the ratio of number of nuclei of material B to that of A will be 1 by E. Right? After what time the material of ratio of number of nuclei is 1 by E. Right? So we have this. So this is Na. Correct? So lambda is 8 lambda. Correct? Hey, will you stop talking? So number of nuclei of A is Na is equal to N naught into e to the power of minus 8 lambda into T. And so time is same. After what time? Now Nb is equal to N naught into e to the power of minus lambda T. Now their question here is after what time the ratio of number of nuclei of material B to A will be 1 by E. After what time? So T will be equal to 1 by E. Correct now? 1 by E. So ratio is 1 by E means Na by Nb. B na? Okay. Nb by Na. ಇಲ್ಲಿವರೆಗೂ ಅರ್ಥ ಆಯ್ತಾ? This will be 1 by E na? Correct? 1 by E. Now e to the power of minus lambda T, e to the power of minus 8 lambda T. Equal to 1 by power is same 1 by E. So if you calculate that T will be equal to 7 lambda. 1 by? Yeah. So it comes down. So when you compare that, the time will be equal to 7 lambda. Artha ida? So option number A, 7 lambda.